Hello everyone, welcome to the third tutorial of ECON1310. Today we'll be talking about probability. Let's start with the admin stuff. So as you got, most of you might know, yesterday I was the first CML closed at 4 p.m. So I hope you guys, this was the first attempt, so I hope you guys had a chance to give it a go. I noticed that most of the students did. A few students didn't even open it, and one student hasn't submitted, which is very important to not to forget to submit. I don't know if the student forgot or just gave up, but yeah, it doesn't submit it by itself, so it's important. Good news is we have a second attempt for CML1 if you're not happy with your grade, or even if you're happy, but if there's still a chance of improving it, I think it's good to give it a go so you practice a little bit more. And the best grade will be is the one that we're going to take, so there's nothing to lose trying for the second attempt. So it opens tomorrow at 9 a.m. as you can see here, and it goes until Friday. So the second attempt, you have just let's say 3 days if you count the business hours, so it's like 2 days and a little bit, in a few hours to do. And also at the same time, CML2, which is based on lecture 3 and 4, will start. You can start to so it will start at the same time, 9 a.m. Wednesday, and you can start trying it after this after this tutorial, definitely. You can start trying it tomorrow, and the tutorial covering lecture 4 would be on Thursday, and then you're ready to do this ones. We will not have tutorials or consultation next week. So if you guys have anything to ask or want to check anything with us, join a consultation this week. We cannot really help you with the CML and go and look what you're doing. But the CML you can discuss with a friend. And I think that's it in terms of CML that I was going to say. Any question regarding CMLs or LBRTs? Let me open the chat. Quiz, yes, exactly. Yeah. So CML and the quiz, I think we will use it the name interchangeably, but yeah, CML is a quiz. Yeah, definitely. So you have, for the CML, you have more time to solve it. You can open and close. The LBRT, you have like a short period to do everything, right? All right, let's move on. So I'm not planning to do it every week, but I'll do it once again. So statistics from tutorial 2, we had a few more people. So we had 33 students comparing to 30 on the first one. So it's a little improvement there, with 28 being people enrolled and 5 that are not enrolled. For the ones that haven't applied to switch tutorial or haven't talked with Dominic yet, please do so. There are some people who might drop the course, and maybe some spaces will be available. I can see there are 5 people on the wait list to join this tutorial, the 4 p.m. one, but probably people have until the 18th to drop. So there might be some spots opening up beginning next week. And the time spent, the maximum time someone spent was 100 minutes. It wasn't me, someone was just a few minutes more, but nothing like abnormally large, which is good, because the minimum time, the minimum time also improved from just 10 minutes from one of the students to 23. It's not good enough for 23, but it's already much better than just 10 minutes. And the mean time improved a little bit to 82 minutes, and the standard deviation dropped to 15. which is good. So we have a mean of 82 minutes and a standard deviation of 15 minutes instead of 24. So people will stay here for all or most of the tutorial. It's always good. Poll participation, also something really good. Answering all the polls jumped from 11 to 20. Answering 3 of the polls jumped from 6 to 7. It's already 27 out of the 33, pretty good. And answering just a few dropped a little bit. And basically 6 people answered 2, 1, or 0, and 0 went from 2 to 3. Let's see. Can you explain CADStat? I tried installing it in Excel with no success. Alex, I had the same when I was studying. I think CADStat was made for a very old Excel. I think Excel 2010. So you don't need it to do your CMLs or to do your LBRTs or the exercises. It is, if you want to use CADStat, you can go to one of UQ computers. They will have in the labs, they will have it installed. But I tried a few times and a few different ways, and I couldn't make it work with the recent Excels. So if you really want, go to a lab, for example, building 69. Otherwise, you'll be fine without it, in my opinion. Oh, definitely not. Yeah, selling it. Can't believe it. Don't buy anything. Yeah, and Excel. If you're a UQ student, you can install Excel using your UQ login. You don't need to buy it while you're a student. So yeah, don't spend money on it. Definitely not $200. All right. Next, any question before I start the tutorial? Any other question? I'm sorry. Or feel free to also open your mic and jump in for the session. Let me see how many people we have. We have 31 at the moment. Really good. If you don't have any question, then we're moving on to begin the tutorial. So let's go. Okay. So tutorial 3. We're talking about probability. I hope you guys had a chance to watch the videos from call. Probability is pretty important, and it is the link that connects what we're talking about before, like descriptive statistics and inference statistics, with what we're going to see in the next weeks. So let's go here. Our objective with tutorial 3 is define the basic concepts using simple probability problems, define the 4 types of probability, use the addition and multiplication rules to calculate various probabilities, construct a contingency table, and calculate various probabilities, construct a simple tree diagram, and calculate various probabilities, test the independence of events using a contingency table. Let's go then. First question. With each purchase of a large pizza at Tony's Pizza, a customer receives a coupon that can be scratched to see if one prize will be awarded. The chance of winning a free soft drinks is 1 in 10, and the chance of winning a free large pizza is 1 in 50. You plan to eat lunch tomorrow at Tony's. So we can start here with A. I will click and look at that. What are winning a soft drink and large pizza mutually exclusive? And I do have a poll for you. Let's go there. Yes, this one. And I will read the question with you. So are winning a soft drink and large pizza mutually exclusive? Are winning a soft drink and large pizza collectively exhaustive? And that's basically the questions I had in the poll. I also added the kind of the format of the Venn diagram we're going to use. And it's important to understand that what we're going, the answer to the first two items are going to define the format of the Venn diagram on the third question, okay? So, are winning a soft drink and a large pizza mutually exclusive? And how do we know that? Does anyone want to jump in on the mic or send chat? Let me open the chat. Explaining your answer for A. We still have, where is the poll? We still have it running. I only have 13 answers up to now. 14, 15. Yeah, let's go, guys. We are 34, so we can get up to 33 answers. 18 answers at the moment. Does anyone want to also, if you want to annotate and draw in the screen, feel free. But first, we're talking about the mutually exclusive. What does that mean? And let me see how many answers we have. I'll start explaining a little bit. 22 answers, very good. So mutually exclusive, it means, as you know, exclusive means it's either one or the other. It can't be both at the same time. So what do you guys think? And for the second question, are winning a soft drink and large pizza collectively exhaustive? This means winning a soft drink or a large pizza, are these the only options? So they're exhaustive. They exhaust all the options we have. Is it the case? And we have 26 answers. Let's push, guys, a little bit more. Let me see how long. Another 10 seconds, maybe, if you haven't answered yet. Look, if you do it, if you answer and it's wrong, there's absolutely no problem. We're not measuring how many you get right or wrong. We're measuring more your participation on those polls. And that's it. Okay, 26 answers. I will show you the result. And look at that. So, are winning a soft drink and a large pizza mutually exclusive? Yes. Why is that? Because it's saying here only one. So, to see if one prize will be awarded. So you can't win both at the same time in the same visit. But are they collectively exhaustive? In fact, no. There is a chance of not winning anything, right? So so it's a yes and a no, and then we're going to draw a Venn diagram.
Just a quick question,
sure.
Francisco.
Yeah.
Does that mean like another way to define collectively exhaustive? Like, I agree that it's no, but could it be another definition that the probabilities have to add to one, like the no?
Yes. That would make them, if you have the probability of all the events and they add up to one, this group is collectively exhaustive. You're right.
Yeah. Okay. Sweet. Thank you.
Perfect. No worries. Yeah. Usually I try to also make things very visual, but there are a few notations that I think it would be important for us to have during this tutorial. And for example, let's call the event of winning a soft drink S. So the probability of S happening 0.1, so because it's 1 in 10, right? And the probability of winning a pizza 0.02 because it's 1 in 50. Hope that is clear. I'll clear this one. I'll also close my annotate. And now we can do a whiteboard. I would like to draw the Venn diagram. I closed the poll, right? And let's see, what can I see? Oh, I'm still sharing. So the Venn diagram we're going to draw. I'll stop sharing. it's actually a separated event. The events are separated. And why is it so? Can someone like jump in and share with us? Why do you think it is separated? It's also, I think I have to stop sharing my screen to go new share. Oh, perfect. So let's draw a Venn diagram. Why do you think these two balls will be separated?
Because there can't be any intersection between them since you can only win one prize.
Perfect. Exactly. So let's try. Can you guys please add the percentages? So this is for soft drink on the left and pizza on the right. Can I have some of you participating here and jumping in to add? I would like a percentage to win soft drink. Sorry, a percentage. No, let's use the right thing, the right notation, or let's say the most common notation when we talk about probability. So 100% means 1. So we will use 0 point something for the chances, the probabilities of things happening. How much is the one for, let me see, let me open chat. How much is the one for soft drink?
0.1.
Perfect. 0.1. How much was the one for pizza? Excellent. I think
0.05.
Yeah, 0.02, I think.
Oh, sorry.
1 in 50. Perfect. Yeah, 0.02. So the thing is, the whole thing here, how much is inside of this rectangle in a Venn diagram? How much is the total, the addition of everything?
1.
Perfect. So if the total is 1, here we have 0 on S, the S event, we have 0.1, and the P event, the pizza, it's 0.02. How much is left for the rest of the rectangle?
0.88.
Yes, perfect. 0.88. So here we have our Venn diagram. We don't have an intersection of the two events. And that is great. I will have a Venn diagram open there in the next slides. But now let's jump in where is it? I will close the whiteboard. Let's jump into another thing. Is it not? I think I'm not sharing the screen anymore, am I? Can you see my screen? I don't think so.
No,
No?
only can see your face.
Okay, I will, let's share again. I don't know why they do it when I close the whiteboard. So look at this Excel. This is, let's see here. It's going to say the joint probability matrix. It will be called other names too, but we know when we're assembling this, and it's important to understand that all of these probabilities, they talk to each other. Let's see. Oh, there you go. Harry had his already. Let's go step by step here. So this is let's say the whole Venn diagram, that the total thing is 1, right? Probability of having the event S or winning a soft drink, 0.1. Probability of winning a pizza, 0.02. So these guys here, this and this have to add to 1. In Excel, we can do this. Oops, equals to 1 minus 0.02. There you go. Equals to 1 minus 0.1. So 90%. So there's a 10% chance of winning a soft drink and a 90% chance of not winning a soft drink. There is a 2% chance of winning a pizza and a 98% chance of not winning a pizza, right? All right. So what we have from the Venn diagram, one thing for us to think together, is it possible to win a pizza and win a soft drink?
No, because they're mutually exclusive.
Excellent. So this would be 0. If this is 0, and these two guys have to sum to this one, so this is equals to this one minus 0. Same thing here. This is equals to this minus 0, right? The thing is, the guy who's left here, what's going on there? All of them also have to add to 1, the guy here. So I could say 1 minus this gives us this number, 0.88, which is exactly the same number we had here, 0.88. So I think that's nice. You can see that both things talk to each other, and the probabilities that we will work in the next exercises too, that will be talking to each other through these things. Any question up to here? Sure. Let's go then. Question B, what is the probability you win a prize? What is the probability that you will not, let me see here, you will not win a prize? I'm launching the second poll. And finally, what is the probability that you will not win a prize on 3 consecutive visits to Tony's? Let's see how it goes. I have one answer. Someone was very quick. So how do we consider the probability of winning a prize? We have a Venn diagram here and also this joint probability matrix. You can use either of them to answer. Probability of winning a prize or not winning a prize. I have 7 answers up to now, and the probability that you will win a prize on 3 consecutive visits to Tony's. I'll give another minute for you guys to think, and we can discuss. Wait, did I show? No. Oh, I think I just showed. Let me see the next one. This is a little bit of advice, and using our notation, let's think about how things are going. The probability of winning is equals to the probability of either winning a soft drink or winning a pizza. And it is equals to the probability of winning one plus the probability of winning the other one minus the probability of winning both. The thing is, what is the probability of winning both of them? Right? We'll clear the draws. So what is the probability that you will not win a prize? And we can think in a way that we can use the probability of winning after you answer 1. You can think about it as 1 minus, sorry, the probability of not winning is 1 minus the probability of winning. So you either win or you don't win. These are all the possibilities. So you can consider that as 1. And usually in probability, that's how things work. You have the probability of something happening, and 1 minus that is the probability of that thing not happening. unless there is a third option that covers it, but that's it. Look, we have 21 answers. I will end the poll here and share the results. So probability of winning a prize would be 0.12. Good job. Half of you guys got a little bit more than half. I put some numbers to make it a little bit confusing, but that's how you could just add both of them. And I did put this minus the probability of winning both, but it's 0 because they're mutually exclusive, right? Second one, the probability that you would not win a prize. Perfect. I think that 15 out of 21 people got 0.88, which is correct here. 1 minus 0.12, 0.88. And for the last one, it was kind of a challenging one, but I can see 10 people got it right. It's basically the chance of going there and not winning is 0.88. The chance of going there 3 times and not winning, it's 1 and not winning and not winning. So not winning and not winning and not winning, which is basically 0.88 to the cube, which is 0.6815. Okay. Any question before we jump to the next one? See, anyone feel free to jump in, open your mic if you feel like, but let me see, someone's typing. No. All right, next question then. Question 2. 15% of new sports car model have defective brakes, and defective steering occurs 5% of the time in this model. You notice that just playing with words, they gave you 2 probabilities, but one written down, one with the number, and continuing here. Assume these problems occur independently. If one or other, but not both, of these problems are present, the car is called a lemon. If both problems are present, the car is called a hazard. Draw both a Venn diagram and a joint probability table. What is the probability that the car is? So let's go. Can see. Sorry, my internet wasn't stable just now. Oh, that's all right. No problem. Let's go. So for the second one, I will call it B for brake and S for steering. So brake, I think everybody knows. Steering is when you have a problem, the wheel that you use to turn. That's what steering means, in case you didn't know. Now let's go. So the total of our matrix is 1, right? The chance of having the brake, going back there, let's see if the chance of, look, 15% of new sports car model have defective brakes. So brake, 0.15, enter, so 0.15. So the chance of not having a brake problem, not having the brake defective is 1 minus 0.15, 85. Now for steering, it was 0.05. Same thing, the difference equals 1 minus 0.05, 0.95. And now, one important thing here to always pay attention. It says, assume these problems occur independently. And this is something we have to pay attention. So when they are independent, it means, let me close this one. It means that the probability of these 2 guys happening, so steering and brake, is equals to the multiplication of each probability. So that means this is equals to this times this. That's what makes it independent. And one thing that we can do is to, let me see. Now, if I dragged, it wouldn't work, but let me see. No, I will just do one by one. I think will work better. This times this one. This times this. So if both events are independent, we can multiply the way I'm doing. And this is how things are going to work, okay? All right, so we have this. So let's draw a Venn diagram. Another share. We have this one. Let's see if there's any minimal chance that we can have both things in the screen. I'll try to drag this one a little bit lower here. New share, whiteboard, share, no, clear all drawings. Where's the Excel? I'm trying something here. Can you guys let me know if you can see both? Not
No.
sure. No, just you can't see the Excel in the bottom. Can you?
Nothing as a whole is white.
Ah, that's unfortunate. Yeah, okay, that's all right. So now we know there is a chance that, oh, for a question. Oh, let's see. If not independent, then what do we do in Excel? So Alex, it will depend. If they are not independent, you can't say the values are just the multiplication, but we will see an example of it next. Yeah, and it can vary a little bit what we do in Excel, but it goes case by case. So this Venn diagram, should we put the circles together or separated? Feel free to open your mic or type on. Yeah, amazing. Thank you, Harry. So together. So I'll put it like this. So that's not the prettiest Venn diagram I did. Do you guys feel like typing the numbers we found? Let's start with the number in the center. I can do this one for you guys. We found that both things happening. It's 0.0075. That was the chance. Maybe I should type something here. Break and steering problems, right? What is the number? Let's start with break. What is the number that is going to come here? Can someone annotate, put the number there, or type on in the chat, or open your mic? The break, this part now. Someone would like to give it a go? So the chance of the break being defective is 15%, right? If you look at the Excel, when I click Excel, I don't think will pop in your screen anymore because you might be looking at the whiteboard. If this whole thing, exactly, Harry, yeah, if the whole thing is 15%, then this part added with this one should be 15. Therefore, this one would be 15% minus the 0.075. So what we have here, 1, 4, 2, 5. The same thing works here for the steering. It's the whole thing is 5%. So 5 minus 0.05 minus 0.0075 will give us 0.0425. And basically adding this 3 will and you know that everything is 1. So subtracting all 3 from 1 will be 0.8075. Okay. That's the Venn diagram. So we did the Excel, we did the Venn diagram. Let me share my screen. So we will have, oops, no. We will have both in here. Can you see, is it clear that they are telling us the same thing, just in different ways, but the information is the same? And from here, think about it, and let's try another poll. I'm launching it, and I want you guys to tell me what is the probability that the car is a hazard, which is when both of them are happening, and when the car is a lemon, which just one of the problems is happening, but not both. And it's just these two questions for this one. I will give you maybe 2 minutes for this one. Oh, sorry. So let's go from the beginning just to fill out the time while you guys are thinking about it. Assume 15% of new sports car models have defective brakes. So the brake, 15% of having a defective brake, therefore 85% of not having. The B line, remember that this notation, the little line, will mean that it is the not. There are other ways of writing it down, but this means not B and not B. And for steering, with S, it's 5% or 0.05, and S line 1 minus 0.05 is 0.95. So the chance of not having a steering problem is 95%. Both of these events are independent. So we can just multiply the, let's see how I'm going to draw it, multiply the probabilities to get the numbers in the center, just because they're independent. And let's see, we have 15 answers. Guys, we are 35. We can do much better than that. It's just 2 questions, 16 answers. So yeah, okay, I didn't give out the answer this time. Oof. The scrolling the mouse, it's giving out everything. I have 19 answers, just another 15 seconds, please. 20 answers. So where is it? So we know that, like, having both problems, how do we find both problems happening at the same time? In this case, we draw a diagram because the 2 events are not mutually exclusive, right? And all right, I will 22 answers in the poll. I'm going to 23, going to close it. And yes, 23 answers. All right, so let's go. First one, a hazard. Perfect. For a hazard, when the car is a hazard, it means both problems are there, brake and steering. So like your steering is not working, and when you try to brake because the car is not going the direction you want, it's also not working. That's a massive problem. So 16% of you got it right. It's right here when the intersection of both events are happening. And the second question, a lemon, is just when one of the events happen. And it's a little bit trickier here. Just half of you got it right. This is the addition of this guy and this guy, but not the third one. Just maybe I should use a different color. Control Z. This and this, just the two of them together. So this is the total is 0.185. Oh, sorry, I didn't share the results. You guys can see the results. And let me not use mouse. Let's go to the next screen. So probability of B, look at the notation, the probability of B and S, this little guy here means, where is it? Means end. Can you see? This is end. And it's the same as multi, because they are independent. We can say that this is the same as this. And this guy here, it's, let's change the color. It's this one. The other one, it's P or S, but not both, because both was the hazard. And we will have basically P of B happening, but not S, which is this guy here. Whoops. And this other guy here. Oh, oops, I wrote it incorrectly. I should have changed it. It was not B at the same time as S happening. Apologies for this one. I'll have to edit. Which is this guy here. S is happening, but B is not happening, right? And yep, the total is 185, adding both. I'll clear all my drawings. I'll stop sharing. Let me open, no questions in the chat. Any question before we move to the next one? There we go. The answers. Always feel free to interrupt me and jump in to ask questions. But I will start moving to question 3 now. Okay. So let's do it. I'll close this one, close this one. So question 3, 17% of the employees in a company have are managers, have managerial positions, and 28% of the employees have MBA degrees. Also, 60% of the managers have MBAs. And that's the situation we come. We were discussing just a little bit before, and particularly with Alex. Let's have a look at how it works for this question. So I'll jump into Excel. Maybe I should just keep Excel small so you guys can look at the question, but still working here. Is it working for you? Can you see both? I would expect so.
Yeah, now you can see the both.
Amazing. Thank you. So let's call MG for manager or managerial position and MBA, right? Where do we start? We start by clicking 1 here. Now, what is the chance of having an MBA? We saw that 28% of the employees have an MBA. So the total just MBA now 0.28. If 28% have an MBA, so 1 minus 0.28, 0.72. Now the managers, I'm kind of doing it backwards, right? 17% of the employees have a managerial position. Let's go there. MG for manager. 0.17. Therefore, how many are not managers? Let's go there. 83% of the people are not, of the employees are not managers. Perfect. Now, challenge. Also, 60% of the managers have MBAs. How do we do that? Does someone want to jump in and explain or send something on chat? So 60% of the managers have MBA. Are we talking about only the people who have and the employee, only the employees, let me be more specific, who have managerial positions? Or are we also talking about the employees who don't have managerial positions? Yeah, good job, guys. Exactly. So we already have, I was going to say, we're only talking about the ones with MBA. Sorry, only ones who have a managerial position. So these guys only, we're only talking about this line. And the total of this line is 17%. And 60% of it also have an MBA. So this one here equals to 0.6 times this guy. Enter. Therefore, what comes in the other cell here for this? We have this and we have the total. What we have in being a manager, but not having an MBA. What do you guys, can someone put it on a chat or open the mic?
0.008.
I think so. I haven't done the math by head. Yeah, 0.
Oh, sorry.
Yeah, it's
Wait.
basically the total minus what we found for the previous one. But you were very close. Good job. Very good job. These two guys, let me move my Excel a little bit up. Just adjust a little bit. These two guys, they have to add up to this one. So basically, to find the value of this one, I got this one with 60%. I like Mika and Wu shared, we could also have calculated as 40% because we already have 60% with MBA. So 40% without MBA, which would 0.4 times this guy, enter, which is the same value. Good job. Amazing. Amazing you guys are participating here. So we have these numbers. Now, look how interesting. How do I find this cell here? Can someone put up? And therefore, I think the answer for both of them will be the same. But could you please help me finding the value for this first one? The employees who are who are not managers, so don't have a managerial position, but still have an MBA. You will notice it's easier than it might seem like. Yep, exactly. We can just subtract we know the total in the column. The same way that the row has totals, the columns have totals too, minus the value we found for the other one. And there we go. Good job, Harry. Then to find this one, it would be the same. One trick in Excel, you could click here and just go there. It will move both values. So these values were the subtraction of these two. Now, by dragging it to the right, the subtraction of these two. Yep. And this is how we filled this Excel, right? Oh, let's go then. Perfect. Probability of being a manager now with a little bit of notation, 0.17. Probability of having an MBA, 0.28. Oh, look at how this information is done here. Probability of having an MBA given you are a manager. And why are we doing it this way? Given you are a manager, how to interpret? It means when it's given you are a manager, and we're only talking about managers. We already know this employee we're talking about is a manager. So 60% of the managers have MBAs. So of all the managers, which is given, we're not talking about not managers. 60% have an MBA. So the probability of having an MBA, if you are a manager, is 0.6. I'm going a little bit around. It will be quite repetitive, but I hope like if someone didn't get the first times, they will get later and later. Like, but apologies if you like we're quick and got it quickly. It can be quite repetitive, right? So, first question: find the proportion of employees who are managers and have an MBA. We have found it already, right? It was the intersection here, or it's MBA and manager, which is 0.102 that we found before. We had our, all right, same value. Then find the proportion of MBAs who are not managers. So maybe look how this question is put. I put this one here as an advice of to think about it. Are you guys able to send on a chat or open your mic or maybe annotate on the screen? Look, the proportion of MBAs who are not managers. Try to see, it's a question put in a different way. And why are we putting the MBA after? So not managers given MBA. So we know we're only talking about employees who have MBA. So we're separating the ones who are manager and the ones who are not. In this case, we're asking the proportion. Let's see. Perfect. MG.
Proportion. Sorry. Maybe it's a proportion of not manager and MBA divided by proportion of MBA.
Excellent. Very good. Also, Tongyang, also good job there. You guys are saying the same thing. Very good. So let me see what I put on the slide. So the proportion of not being a manager and having an MBA, not being a manager and having an MBA, 0.178, divided by the total of MBA, which is the probability of having an MBA, 0.28. I should have improved this one. I'll fix it real time. Oh, sorry. No. Sorry. This, you're not dividing twice. It's a little mistake of mine here. So 0.6357 is the answer. This number divided by this one. Okay, any question? Go back to my slides. Can I do it without showing the next question? I will fixing things real time. All right, we're dividing just once. Let's go. So next one. Oh, already put an advice there. Are the events being a manager and having an MBA independent? Justify your answer. And remember, to be an independent, it means the probability of having an MBA given you're a manager is the same as the probability of having an MBA because they're independent. It doesn't matter if you're a manager or not. The probability of having an MBA is the same. That's what is being independent. What do you guys think? And I've explained, when you look at in the matrix, I explain in another way. It would mean if they are independent, that we just multiply these two guys and we'll get this one. Multiply these two guys and we get this one. let me, for example, this times this equals to this one. And then this times this equals to this one. And there you go. So do you think it is or is it not independent? Or they are independent or not?
It's not independent.
Perfect. It's not. So the thing is, well, okay, does not equal. Excellent. Very good. Very good. What throws us away, you will notice, there was this extra information here. 60% of the managers have MBAs. When we added that information, that we would probably realize, yeah, we're probably not talking about independent events. Well, it could be different too. It maybe they would give us this information and they would say, what would be the right number? Managers have an MBA. 28% of the managers have an MBA, but 20% of everyone has an MBA. So if they said 28 in here, this would still be independent, because then everything would work the way we wanted. Because it's the same as to find this number, we would multiply this by 0.28, which is the same. Well, I'm not drawing anymore. It's too horrible. It's the same as multiplying by 0.28, which is the same as multiplying by this guy here. So the rest of the table would fill out the way we want. It would happen this way because we have just yes or no for one event and yes or no for the other one. So as soon as you have one, the rest is kind of automatic, which won't be for the next question because we have more than 2 options for each event. And do you guys have any question about this one? I will clear the screen. I hope it's making sense what we're getting. I think we commented before like about not being independent and how to fill the table. Now you guys saw we had another table where the events are not independent. Let's go to the next one where the information is coming in a little bit in a different way. Slightly different. Basically, just put 2 numbers there. So, final question for this tutorial. Consider the company that was interested in how employees use the 2 floating holidays that were part of their package. The data are shown in the contingency table, another name for the joint probability table. Contingency table. Maybe the name is different because it's not showing probabilities of that. So type of job, we have many managers or managerial positions, jobs, clerical and marketing. And then some of them took actual holidays, the others added those days to vacation, and others took some random days. And we put it all together in a table. Let me open the table that I want. I kind of filled part of the table. Look at that. Thing is, we have big numbers there. And this is a contingency table. And how do we deal with it? How do we transform to what we're used to, where all of them add to 1? And anybody want to have any guess of how to deal with these numbers? Anyone to risk? Here, if you add all the numbers together, let's try. Let's find out how many options, how many items we have. Basically, you can see that it's the same worker can be represented just once here, right? So 5 plus 13 plus 13 plus 53 plus 17 plus 46 plus 78 plus 51 plus 32 plus 5. We have 300 observations there. So if we have 300 and I want to transform this in the table that ends to 1, I just need to divide each of the numbers by 300. So my total, 300, just to be fancy, I'll put 300 divided by 300. Then we have 1. So first one, I just put a single letter to make it look a little bit better. So managerial position, took H, actual holiday. We have 5. So I'll put in Excel equals to 5 divided by 300. And I'll do the same for all the other values. Equals 53 divided by 300. Equals 17 divided by 300. Equals 46 divided by 300. And equals 78 divided by 300. Let's go to the next one, the ones that took random days. 51 divided by 300 equals 32 divided by 300 and equals 5 divided by 300. Amazing. If I add all of them, let's see how much it adds to. Well, 1.0000. Excellent. So these are the numbers we have. We can also get totals there. Excel is very nice. It has a nice button called auto sum, and it's pretty smart. It knows we're talking about a row there. I will drag this guy. You will see that the second one is adding the second row. Third one is adding the third row. And when I'm down here, if I click auto sum, it's summing the column instead of the row. I will drag it to the right. And look how interesting. If we add these 3 guys, it adds to 1. If we add these 3 guys, it also adds to 1. How cool is that? I don't know you. I do like it. Yeah. So, all right, let's go. I think I've saved the table. It's in here. And let's look at the first item. Find the probability the employee took the probability the employee took the actual holiday given they were managerial level, that they had a managerial position. All right? What is the question here? Given they were, let me put the annotate. This is important. Given they were managerial level. So who are we talking about? Anybody want to give it a go? Excellent. Let's see. Yep. Very good. Yeah. Let me get out of the pencil. So that's what we're talking about. Everyone who has a managerial position. So given, and just the ones, the proportion, or just the ones who took the holiday. So we're only looking at these guys, right? And this is the total. And so how much this, what is the proportion of this in regards to this, with regards to this? So let's go. We have an answer in the chat already. Thank you so much. It's the chance. You know that the end or the intersection is this cell in here, And then we're dividing by the total, right? Which is divided by 0.0167 divided by 0.2433, which is equals to 0.0685. That's the answer for this one. The second and third one, you see they're not too different. So different color. What is the probability that a marketing employee added the holiday to their vacation? Any chance I can have it in the chat? Or open mic, even better. Let me see, I think I have then jump to a little bit of advice. So V for vacation, given you are marketing, and I use the K for marketing. Yes, excellent, all right, thank you. So V over K, it's 0.7574. Finally, C, not too different. What is the probability that one of the clerical employees will take a random day holiday? So we're only talking about clerical. Drawing. One of clerical employees. It means we're not only this line. We're not talking about anybody else on the other two lines, just this one. Oh, sorry, I got the wrong one. Whoops. Just clerical is C, just this one. If you're paying attention, it's just testing you. Excellent. This divided by that one, so I'll just move on. Whoop. 352. Let me move 0.352. Exactly what you guys said. Great job. So let's go now. The last two will be a little bit more challenging. Nothing too difficult. But what is the probability that a managerial employee added the holiday to their vacation or took a random day? So we're not talking about just one thing anymore. It's either one or the other. Thank you, Harry. So I will click. So we're only talking about managerial employees, right? So we have the M. Let's draw a little bit here. M, because we're talking about managerial employee. So only this line in here. Then we want to know when they took, let me put another, even other color, either vacation or a random day. Vacation or a random day. I think I'll put in eyeglasses in a person here. And you know that this one here is an or, right? So it can be, it's one plus the other, as Harry put it there. So vacation or random day. So Harry, yeah, perfect. Now I think you got a holiday in there. It's the only difference, but that's a good job anyways. And I'll now clear because like I'm making a mess with the drawing, but look how it goes. Also important to think, if it's either this or this, you can also think that it is actually the not holiday. So from everything they did, just take the ones that didn't put their days to holiday. A little bit, another advice here. It's another way of writing the same thing. how do we go from there? We could have probability of not holidays and N on C, which is the same thing as adding up these two guys. Look, 0.0567 plus 0.17. Yep. Divided by 0.2433, which finds a 0.9315, right? And finally, last one. Are the type of job and holiday independent? Explain. And let's remember, once again, how do we find if they're independent or not? We talked in the previous, at least the previous two questions. So I would like to give you guys some time. If you don't mind opening the mic, of saying yes or no, but also explaining why you're giving that answer, or sending on the chat. How does that sound? So are the type of job and holiday independent? Anyone? We just did it. We were talking about it in the previous two questions. Maybe three, maybe all the questions. I know it demands a little bit of work. Yeah, nice, the answers, right? Who wants to explain why? Thank you for answering. You don't need to do the calculation. Yes. All right, that's good enough. Amazing. Very good. So, as Harry gave an example, if independent, the probability of being a manager and take the holidays, so M and H, here would be the same as the multiplication of both. But actually not. I think, Harry, you got the same example that I typed down. So being a manager and having a holiday would be the same as being a manager. But being a manager and having a holiday ended up to 0.0706. Let me see. Yeah, the multiplication of both. Did I do it right? Oh, I did it in a different way. Being a manager, given you got holidays, but they are not the same. It would be the same as multiplying. It's also, let me see here. Let's do the multiplication. So 0.2433 multiplied by 0.2367 equals 0.05758. That's not the number that we have here. So they're not independent. So it depends. The proportion of people or type of holiday they are taking depends on the job position. Or the other way around, the job position depends on the type of holiday they're taking, which is weird to think, but that means not being independent or being independent. And that's it for today. I will end the recording. Thank you so much, guys, for coming. For the people watching from home, good luck with everything. And I'll stay here on for the rest of the tutorials. If you guys want to ask something or after I stop recording, feel free to do so. Have a good weekend. Oh no, sorry. I'll see you on Thursday, actually. Bye.